The digital signature is a mechanism that verifies the authority of digital messages as well as documents. It is very popular because it provides more security than other signatures. In Java, JDK Security API is used to create and implement digital signatures. And in this video, we will discuss the digital signature mechanism and also implement the digital signature mechanism in Java program. A digital signature is a mathematical technique used to validate the authenticity and integrity of a message, software, or digital document. And it is a kind of electronic signature to sign a document, mail, messages. And it is same as a handwritten signature, seal, or a stamp. And it is widely used to verify a digital message, financial documents, or ID cards. A digital signature is intended to solve the problem of tampering and impersonation in digital communications. A signature confirms that the information originated from the signer has not been altered. Digital signature make assurance on authenticity, integrity, non-repudiation, and notarization. Sometimes these two terms, that is electronic signature and digital signature, are misinterpreted. The main purpose of electronic signature is similar to that of wet signatures. Like wet signature, electronic signature also demonstrates the verification process. However, electronic signature work on specific criteria that require you to verify certain things before signing a document electronically. Once you have verified the required entities, you can sign the document with your actual sign via stylus or by finger on touchscreen. Whereas digital signature is a kind of electronic signature which is used to secure a document by embedding a fingerprint and encrypting them. So if you want to secure documents, you can use digital signature. On the other hand, the electronic signature can be used for verification purpose only. Okay, let's see how digital signature works. Digital signature are based on public key cryptography, also known as asymmetric cryptography. It uses public and private keys to encrypt and decrypt data. The one key in the pair which can be shared with everyone is called public key. The other key in the pair which is kept secret and it is only known by the sender is called private key. The individual who creates the digital signature uses a private key to encrypt the data, while the only way to decrypt the data is with the signer's public key. If the recipient can't open the document with the signer's public key, then there will be a problem with the document or a signature. This is how digital signatures are authenticated. Also, the digital signatures use a cryptographic algorithm to ensure the authenticity. Digital signatures work by using a private and public key authentication framework, and they are required to prove that the digital document was not changed. This is done by generating a unique hash for a document and then encrypting it by using a private key of a sender. The sender's algorithm will generate two sets of long numbers known as public key and private key. Once these keys are generated, the provider encrypts the document using the private key. On the other hand, the receiver will decrypt the same document matching the public key of the provider. The digital signature is an encrypted hash of a message or a document. It means that the digital signature generates a hash from the message. Hashing is one of the core elements of digital signature system. It is the process of transforming data of any size into fixed size output. And this is done by special kind of algorithm known as hash functions. The output generated by hash functions is known as hash value or message digest. After that, the generated hash is encrypted with private key. For that, we can use RSA or SHA algorithms. When we send a message, the encrypted hash and corresponding key is also sent with the message. When a receiver received a digitally signed message, the receiver generates a new hash from the message. After that, it decrypts the received hash by using a public key. At last, it compares both the keys. If they are equal, the digital signature is verified. And this is the digital signature flow. Now let us learn how to create a digital signature. And these are the steps to create a digital signature. The first step is to create a key pair generator object. As I mentioned earlier, the digital signature requires a private key, also its corresponding public key, in order to verify the signature. Sometimes the key pair is already available in files, if not we need to generate it. We can generate a key pair by using key pair generator class. Here it generates keys with 2048 bits in length. And we are passing the algorithm name as an argument, where DSA is an algorithm to use. To encrypt the message, we need an algorithm and a private key. So here we are using DSA algorithm. Now we need to initialize the key pair generator. And we use the initialize method to initialize the key pair generator. This method accepts the integer value representing the key size. Next, we generate the key pair using key pair generator method. Using key pair class, we generate public and private keys. Next, we need to load the private key for signing. We get the private key using getPrivate method. And next step is to sign the data. And here we create an object of the signature class using the getInstance method. And thus the getInstance method of signature class accepts a string parameter representing the signature algorithm and returns the respective signature object. In this example, we choose the signing algorithm SHA256 with DSA, which is a combination of hashing algorithm and an encryption algorithm. Then we initialize the signature object. The initialization method for signing requires private key. So we will use the object priv key of private key that we have created above. And next we input the signature bytes. And here we will supply the data to the signature object for which the signature was generated. And finally we calculate the signature using sign method. The sign method of the signature class will return the signature bytes of the arbitrary data. And finally we will print the digital signature for the given text. Now let's see the program. And this Java program accepts a message from the user and generates a digital signature. The import is a keyword used to import a package, class or interface. An import statement tells the compiler the path of the class or the entire package. Packages consist of classes. Classes in the package consist of methods and variables. A class has a full name which comprises of package name and class name. If you need to use a class in your code, you need to give the compiler the full name of the class. So in that case, you can use the import statement or you can type the fully qualified name in every place you use that class in your code. So the import statement will bring certain classes and entire packages into visibility. As soon as imported, the class can be referred directly by using its name. Java.Security provides the classes and interfaces for the security framework. This package supports the generation and storage of cryptographypublic key pairs as well as the number of exportable cryptographic operations, which includes message digest and signature generation. Java.Security.keyPair is a Java key pair class which represents an asymmetric key pair, public key and private key. The Java Security API makes heavy use of both secret key and public key cryptography. And key pair as a class is a simple holder for key pair, which is a public and private key. And the key pair generator class is used to generate pairs of public and private keys. The basics of creating and managing keys are provided by the key interface. And the key pair, key generator and key pair generator are the classes in the Java.Security package. A key pair instance is typically used when performing asymmetric cryptography like encrypting or signing data. You will normally obtain a key pair instance from a Java key store or a Java key pair generator. You can access the public key of key pair by calling its getPublic method. Similarly, you can access the private key of key pair by calling its getPrivate method. The Java key pair generator class, that is java.security.keyPairGenerator, is used to generate asymmetric encryption and decryption key pairs. An asymmetric key pair consists of two keys. The first key is typically used to encrypt the data. The second key is used to decrypt the data, which is encrypted with the first key. The private key is used to encrypt the data and public key can be used to decrypt the data again. Actually, you could also encrypt the data using public key and decrypt it using private key. The private key is normally kept secret and the public key can be made publicly available. To use the Java key pair generator, you must first create a key pair generator instance. Creating a key pair generator instance is done by calling a method, that is getInstance method. So this line of code will create a Java key pair generator instance. The getInstance method takes the name of the encryption algorithm to generate the key pair. In this example, we use the name DSA. Depending on the algorithm the key pair is generated, you have to initialize the key pair generator instance. Initializing the key pair generator is done by calling its initialize method. So this line of code will initialize the Java key pair generator instance. So this line of code will initialize the key pair generator to generate keys of 2048 bits in size. Private key is an interface in Java.Security package. This interface contains no methods or constants. It merely serves to group and provide type safety for all private key interfaces. The Java signature class can create a digital signature for binary data. A digital signature is a message digest encrypted with a private key of private and public key pair. Anyone in possession of public key can verify the digital signature. So before you use the Java signature class, you must create a signature instance. You create a signature instance by calling the static getInstance method. So this will create a Java signature instance. The string passed as a parameter to getInstance method is the name of the digital signature algorithm to use. So once you have created the Java signature instance, you need to initialize it before you use it. You initialize the signature instance by calling its init method. As you can see, the signature instance is initialized with private key of private public key pair. Okay, when the signature instance is initialized, you can use it to create digital signatures. And you create a digital signature by calling the update method one or more times and finishing with a call to sign. Scanner is a class in java.util package used for appending the input of primitive types like int, double, and string. And this line of code will import the scanner class, which is defined inside the util folder, which is inside the Java folder. The import are used to know the class you want to use. Java.util represents the path and scanner is the class you want to use. Public is a keyword in Java. A Java public keyword is an access modifier. It can be assigned to variables, methods, constructors, and classes. A class is a group of objects which have common properties. It is a template or blueprint from which objects are created. It is a logical entity. And here we are defining a class named as creating digital signature. Here the class is made public. Classes are package provided by default. That is, the class is not accessible outside the package. By making a class public, you can use the function and method of this class in another class too. Therefore, it is available outside the package. For example, if there are two public classes are available in different packages, and it can be interlinked. So if class is public, it can be referenced by other classes in your program. And this is the main method, which is the entry point of any Java program. Public is an access modifier, that means it can be accessed by any other class in the program. Static is an access modifier, that means when a Java program is loaded, it will create a space in memory automatically. Void is a return type and it does not return any value. Main is a method or a function name. It is a first method to execute by Java virtual machine. String args is a command line argument. It is a collection of variables in a string format. Throws is a keyword in Java. Throws keyword is required only for checked exceptions. In a program, if there is a chance of raising an exception, then compiler will warn about it. And it is compulsory to handle that checked exception. Checked exceptions are checked at compile time. For example, IO exception, interrupted exceptions, or checked exceptions. Unchecked exceptions are not checked at compile time but at runtime. For example, arithmetic exception, null pointer exception, array index out of bounds exception, and exceptions under error class are unchecked exceptions. Usually we don't need to handle unchecked exceptions. It's because unchecked exceptions occur due to programming errors. As I said earlier, it is compulsory to handle the checked exception will get a compile time error. To prevent this compile time error, we can handle the exception in two ways, by using try catch or by using throws keyword. So when we use throws keyword, it will delegate the responsibility of exception handling to the particular method or the JVM. Then that method is responsible to handle that exception. And this statement creates an object of scanner class which is defined in java.util.scanner package. Scanner class allows user to take input from console. System.in is passed as a parameter in scanner class. It tells the Java compiler that the system input will be provided through console keyboard. So when you call this statement, you make a new object of scanner class. So you make a new scanner. At the same time, you are calling the so-called constructor of the class with a parameter system.in, which means it's going to read from the standard input stream of the program. So when you are calling this method, you execute this method from the object you just created. As you see, this method returns string. So this method of that object which allows you to enter some text and it will be parsed into a string. So if you want to use that string, you need to assign to a variable. And this line of code will print this message, that is enter some text. This line of code will read a string written by the user and it will assign it to this variable. To be more precise, the input is read with the scanner tool's next line method. The call sc.nextLine is left waiting for the user to write something. When user writes something and press enter, the provided string is assigned to a string variable. In our program, the variable is msg and this variable is referenced here. Here is where we are converting the given string into byte array. And here is where we are creating a key pair generator object. Key pairs are generated through key pair generator class. A key pair generator instance is created using static getInstance method. And here we are using an algorithm name to specify what type of keys are needed. To encrypt the message, we need an algorithm and a private key. So here we are using DSA algorithm. The key pair generator class is used to generate pairs of public and private keys. There are two ways to generate a key pair, in algorithm independent manner and in algorithm specific manner. The only difference between the two is the initialization of the object. And here we are using algorithm specific initialization. So the key pair generator class provides getInstance method which accepts a string variable that represents the required key generating algorithm and returns the key generator object that generates key. So this line will create key pair generator object using getInstance method. Once the key pair generator object is created, it must be initialized. The key pair generator class provides a method named initialize. This method is used to initialize the key pair generator. This method accepts an integer value representing the key size. If user does not explicitly initialize the key pair generator, each provider must apply a default initialization. For example, the Sun provider uses a default modular size or key size of 1024 bits. In our example, we initialize the key pair generator to generate keys of 2048 bits in size. This line of code will generate the pair of keys. A key pair can be generated using generateKeyPair method in the class java.security.keyPairGenerator. And this method requires no parameters and returns the key pair that is generated. So every time this generateKeyPair method is called, it generates a new key pair. And thus it generates a key pair and returns the key pair object. From this key pair object, you can get the object containing public key and private key. For digital signatures, the owner of the key pair uses their private key to encrypt the signature. You can get the private key from the generated key pair object using getPrivate method. So this line of code will get the private key using getPrivate method. The private key is kept secret by the creator of the key. This private key will encrypt the sensitive information into ciphertext. And private key is used for digitally signing documents. When the signer electronically signs a document, the signature is created using signer's private key, which is always securely kept by the signer. So this line will get the private key from the pair. GetPrivate method is one of the major methods in keyPair class. This returns a private key object representing the private key in the key pair. Now we create a signature object. So before you can use the Java signature class, you must create a signature instance. You create a signature instance by calling a static getInstance method. The getInstance method of signature class accepts a string parameter. The string parameter representing the required signature algorithm and returns the respective signature object. So this line of code will create an object of signature class using getInstance method. In this example, we choose the signing algorithm SHA256 with DSA, which is a combination of hashing algorithm and an encryption algorithm. So once you have created the Java signature instance, you need to initialize it. You initialize the signature instance by calling its init method. And here is where we initialize the signature object. The init sign method of signature class accepts a private key object and initializes the current signature object. This line of code will initialize the signature object created in previous step using init sign method. Byte array is an extremely powerful class that can be used for many things related to data manipulation, like saving game data online, encrypting data, compressing data, and converting bitmap data object into PNG or JPEG file. The byte is one of the primitive data types in Java. The byte data type is an 8-bit signed 2's complement integer. It has a minimum value of -128 and maximum value of 127. The byte data type can be used for saving memory in large arrays. So this line of code will convert a string into byte array. A string is stored as an array in Java. To convert the string into byte array, we translate the sequence of characters into sequence of bytes. In Java, we can encode the string into byte array in multiple ways. There are 3 variants of getBytes method. We are using the default method. The getBytes method is used to encode a specific string into sequence of bytes using the named character set and storing the result into new byte array. If you do not pass any parameters to getBytes method, it will encode the string using platform's default character set. MSG is an object of the string class, and this object of string class will hold the text from user, and that message is encoded by getByte method, and thus the content of the string is copied to byte array. Now we are going to add the data to the signature object. The update method of signature class accepts a byte array that represents the data to be signed or verified and updates the current object with the data given. So update the initialized signature object by passing the data to be signed to the update method in the form of byte array. The sign method of java.security.signature class is used to finish the signature operation. And it stores the resulting byte in signature. And here is where we are getting the signature bytes. Actually, this line will sign the message and signature will hold the actual signature. And this line of code will print the signature. Now let's execute this program. Open Notepad and copy paste the code. Now save the file. Always name the file with class name followed by .java. To run the file, open command prompt. Change the directory to D, which is where our program is located. Now compile the program with this command. After compilation, the Java file is translated into class file. Now run the file and enter some text and hit enter. Now the signature for the given text is created.